So we'll see the next example. So the question is, find the area of a rhombus of side 13 centimeter with one of its diagonals 24 centimeter. Now we'll see what is the area of the given rhombus. So we discussed about the features of a square and a rhombus. And what are the features of a rhombus? For a rhombus, all sides are same and diagonals are not same, but they bisect each other. So say we have a rhombus of side 13 centimeter. So all sides is of length 13 centimeter. So the diagonals here, they bisect each other. And what is area of a rhombus? So for a rhombus, area is half into product of the diagonals. So here side is given and one of its diagonal is given as 24. So we can take either the vertical diagonal or the horizontal diagonal as 24. So one diagonal is given as 24. So suppose if you take as the horizontal diagonal as 24 and as the diagonals bisect, the full length is 24. What will be length of this portion? It will be half of 24, 12. So now we need to find the other diagonal to get the area. So if we know the length of other diagonal, we can calculate area of the rhombus. And how can we calculate this other diagonal length? So here we have a right angle triangle. So in the rhombus, diagonals bisect at right angles. So here we have a right angle triangle. So I'll draw this triangle here. So this part is drawn here. And what is the hypotenuse length? 13. And the base is 12. And how to calculate height of this triangle? So we can use the Pythagoras theorem. So hypotenuse square will be sum of squares of other two sides. So here hypotenuse is known, and how to find this side? So we'll take this as x, and this x square is got by squaring the hypotenuse and subtracting the square of the other side. So 13 square minus 12 square. So what is 13 square? It is 169 minus 144. So x square is 25. And what is x? So x square is 25. So we get height of this triangle as 5 centimeter. And now this length is 5. So for this triangle, right angle triangle, the height is 5. So this part is 5. Now what will be length of the whole diagonal? So here this is the vertical diagonal. So if this is 5, the other part also will be 5. And now what is length of the other diagonal? It is 5 plus 5, 10. So now with the one of its sides, so here side is given as 13. With the side and one of its diagonal, we have found the length of the other diagonal as 10. And now we can calculate the area. So area is half into d1 into d2. So area of this rhombus is half diagonal, one of its diagonal is 24. So it is given, and we found the length of the other diagonal as 10. And now what is the area? It is 120 centimeter square. So area of the rhombus is half into product of the diagonals. One diagonal length is given and one of its side is given. So with that we found length of the other diagonal as 10 centimeter. So area is half into 24 into 10 or 120 centimeter square. So we will go to the next question. So the next example is, what is the maximum length of a rod which can be kept in a rectangular pencil box of dimensions 20 centimeter, 5 centimeter and 4 centimeter. So here rectangular box is the cuboid. So where we have the length, breadth and the height. So when the dimensions are given in this pattern, the first one is the length, the second one is the breadth and the third detail is the height. So length of the box is 20, breadth is 5, height is 4. So maximum length of the rod is as. So in a cuboid, which will be of maximum length? So the diagonal will be the maximum length. And how to find the diagonal? So we have found how to find the diagonal of a cuboid. Now using that we can find the maximum length of the rod which can be kept in the box. So we'll see the working. So for a cuboid, so diagonal is root of length square, breadth square into the height squared. And in a cuboid, diagonal will be the maximum length. So to find the maximum length of the rod, it is enough if we calculate the length of the diagonal. And what is the length given? So length is 20 centimeters. So breadth is 5 centimeters and height is 4. Now substituting for L, B and H, squaring and adding, taking square root, we get length of the maximum length of the rod. And 20 square is 400, 5 square is 25, 4 square 16. So adding all, so 441. So taking square root, we get the maximum length of the rod. And now what is square root for 441? It is 21. So answer is 21 centimeter. So in a cuboid, maximum length will be the diagonal. So here, the one end to the other end which is drawn will be of maximum length. So diagonal will be of maximum length. So finding L square plus B square plus H square and taking square root, so we get the answer. So answer is 21 centimeter. So we'll see the next concept.